Okay, here's our last counting problem involving the number of paths through a grid. We're still trying to get from A to C with one stop at B, point B along the way, but the catch here is the entire center of our grid is missing. Think of it as a blockade of some sort or a body of water. We're not allowed to go through the middle of our grid. There's no paths through the very center of our grid. So how do we count this type of a problem? Well, nothing has changed a whole lot other than the big hole in the middle of our grid. If we can find the number of paths to get to point B, then we just need to multiply those number of paths by the number of paths to finish off our problem here in getting from B to C. So we're still going to use our fundamental counting principle, but of course we need to figure out how we're going to get from A to B and sidestep that big hole in the middle of our grid. So if we put an extra point on our grid here, point P, and if I can count all the paths to get from A to P, all of those paths are going to continue flowing right to point B, because remember, we're still only moving up and to the right. So if I can figure out the number of points to get to, number of paths to get to point P, that's going to give me pretty good idea of how many paths are going to get to point B, because they will flow also to the right. So how do we count the number of paths from A to P? You can count the number of steps involved there. That's 1, 2, 3, 4, 5, 6 up and 3 over. So of course that's 9 steps in total, so we can count that 2 different ways. Out of those 9 steps, we can choose exactly 3 of them to be steps towards the east, or we also could have counted 9, choose 6 of those 9 total steps. We could have counted 6 northern steps as well. So there's half of the battle. Now we look at the bottom part of our grid and put another point Q on our grid here. And if we recognize, if I know the number of paths to get to point Q from A, of course, is our starting point, those paths can continue flowing up to B. So similarly to how we just counted from A to P, to get from A to Q in blue here, we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9 over and 2 up. So that's going to be a total of 11 steps, and we can choose exactly 2 of them to be steps in the northern direction, or 9 of them to be steps in the eastern direction. Whatever works for you, both will be mathematically the same. So that means we have our problem kind of narrowed down now. We know the number of paths to get from A to P and also A to Q. And if you're wondering how we're going to use those, well, this is how we're going to do it. All of those paths from point P and point Q can flow right and up and coalesce, I guess, at point B. And of course, that's going to be the sum of those 2 combinations. So the number of paths from A to P plus the number of paths from A to Q continue through to point B, and now we're in the home stretch. So now we just have to consider the easy part, because that's all covered now, that gray section of our grid, how to get from B to C, and that's just 3 steps over and 2 steps up. So we can count that either as 5, choose 3 steps east, or 5, choose 2 steps north. Again, doesn't matter, and there's where we have to use or recognize that we have to use our fundamental counting principle to multiply the total number of paths in the gray area by the total number of paths in, I guess, the pink area. And of course, that's to get from A to B first, and then those total number of paths have exactly 5 choose 3 options to finish off and get from point B to point C. So let's wrap up. We did all the hard part. Now it's just some calculator punching. So you can check these 2 combinations on your calculator. 9 choose 3 or 6 will give you 84. 11 choose 2 give you 55. And of course we add those together. We're going to get 139. And as you see on the screen here, we're multiplying those 139 paths, the sum, by 10, because there's exactly 10 ways to get from B to C in that pink section of our previous diagram. So all we got to do is multiply 139 by 10, and we have our answer. So there's 1,390 paths to get from A to C and stop at B along the way, and we've dealt with that kind of bizarre gap in the middle of our diagram.